So here's the problem set for sections 1 and 2 of Chapter 1, Numbers, of Calculation in MathML, Part 1, Algebra. In this video, we're only going to cover these first 3 problems, which are elementary, so that we can focus a bit more on MathML syntax and semantics. If you're just jumping into the sequence now, or you simply want a refresher of the chapter material for this problem set, here's a link for the previous video. I'll put it in the description below as well. Alright, so let's get to it. Great. So all we need to prove these first 3 identities will be the associative property of addition and the commutative property of addition. And we're going to organize our inferences in a blockchain of equalities as follows. Perfect. So in this first step, we're simply going to resolve the quantizing parentheses for both terms, applying the associative property of addition. In step 2, we're simply going to shuffle the terms about the operators, such that we can group a plus d and b plus c by commutativity. And finally, in step 3, we can once again quantize terms using associativity, generating as our final result the binomial quantity a plus d plus quantity b plus c. Perfect. Problem 2 is nearly identical to problem 1. However, in this case, we want to show that quantity a plus b plus quantity c plus d equals quantity a plus c plus quantity b plus d. So I'll make a comment here on MathML attribution logic. Notice that I'm switching here from indicator type monomial to addend and augend. What changes here is the context scope in which this particular number is being referenced. Now there could be any amount of reasons why I might do that in any given computation or calculation or proof. In this instance, in the problem statement, monomial refers to the unknown quantity of an algebraic expression, while addend and augend in the blockchain of equations refer to the unknown quantities of an arithmetic expression. Again, we're going to resolve parentheses on the level-lateral side of the equal sign using associativity, thus obtaining a commutable quadrinomial, which once again we can binomialize using associativity. Problem 3 is much the same as 1 and 2. However, in this case, we're dealing with subtraction. So we're going to show that quantity a minus b plus quantity c minus d equals quantity a plus c plus quantity minus b minus d. So here, on line 234, is our first instance of subtraction. We're going to instantiate the element with a context scope of arithmetic and apply the indicator attributes minuend and subtrahend. Step 1. Resolve the quantizing parentheses. Step 2. Commute the constants to obtain the required order of terms. And once more, binomialize the quadrinomial. And we're done. Perfect. See you in the next one.